Mm.
Hello, guys. Good morning. Good morning, sir.
Good morning, sir. Good morning, sir.
Very good morning.
Good morning.
Very good morning. Very good morning, guys. Very good morning. Do morning to all of you. Very good morning. Very good morning. Agatha, good morning. David
Good morning,
Miracle,
sir.
good morning. Very good morning, guys. I hope you're all doing good. Yes? Yes or no? Okay, so what chapter, Edric? Remind me.
Um, Chapter 16. Angles in a circle and cyclic quadrilateral.
And second tangent one.
Yeah.
Let me check which one is easy. I mean, which one is smaller?
Sir,
Tangent second.
Uh,
Yes.
um, I have a small doubt in the upcoming exam chapter.
The carbonate compound.
Yeah.
Okay, so we'll take that chapter on Thursday. Is it okay? Happy for everyone? Or
Yeah.
Wednesday you want?
Friday's, sir.
Friday's the
Friday is the
exam, I
test.
bet.
Yeah, Friday's exam. Uh, good.
You tell me, guys, when to take
Wednesday?
Thursday or Wednesday. Okay, Wednesday. So today is Monday. So let your man be there. Man is basically in Hindi college mind. Okay. So we will do chapter number 17. I will put a heading. Chapter number
Now we're doing maths
17.
and science together, right?
Yes, yes. Second, tangent and their properties. And and their properties. Okay. Now, basically, we will learn about a new thing called as tangent. So before starting this chapter, first we will learn about something about circle. Everyone, please pay attention. Everyone, please pay attention. So, for example, this is a circle. Not for example, basically it's a circle only. This is the center of the circle, and this is called as radius. R stands for R stands for radius. Everyone, turn on your camera, please. I request Mr. David, please turn on your camera. Okay. Now, now everyone, please pay attention. If I will draw a line from the center of the circle to this point, this is called as diameter. This is called as diameter. Okay, this is called as diameter. So we have radius and the diameter, and the outer circle, like outer, uh, the circular part is called as circumference. Circumference. Okay, this is called as what? Circumference.
Sir, can circumference also be the perimeter of a circle?
Yeah, circumference. We can say we can say circumference as a not prime minister, it's perimeter. Perimeter of a circle. I mean circle. Okay, circle. Okay. Now we have more information about this, that a line which is starting from the circumference and joining the circumference without touching the center of the circle is called as chord. So hence this is called as what? Chord. Not chord, it's chord. David, it's chord.
Sir, chord is
Yeah.
chord is a short version of the diameter.
Yeah. Yeah, correct. Why it is so? Because we can say that like if I will go down to the circle, I will I will find it out that the chord distance will decrease. The distance between the chord will decrease like this. Uh-huh. Like this. Okay. But in the center, it is a longest chord because it is also the center of the circle to this. Okay. So the longest chord is called as diameter. So diameter is a longest chord. We should remind that the diameter is the longest chord. Okay. Now everyone please pay attention. Okay. Diameter is the longest chord, and there's a relationship which is called as diameter is equals to twice of radius. Diameter is equals to twice of radius. Everyone got this? Do you have any problem in this?
No, sir.
No? Okay. Now, more information that we should know. Miraculin, are you getting this, beta?
Yes. Yes. Yes.
Okay, perfect. Now, more information is that this is called as what? This is called as sector that we learn.
Yes.
This is called as minor sector. Okay. And the rest, this green part is called as the major sector. We learn this. Okay. And the formula we learn this. I hope you guys remember that formulas.
Theta
Everyone
upon
understood what I'm trying to say?
theta upon 360 into pi r square and 360 minus theta upon 360 into pi r square.
Very good. So we learn all this thing. And then we learn this thing also. Like the chord of a circle make what? Can you tell me, Edric? The
Yeah.
chord of a circle make what?
Segment.
Very good. This is called as what? Minor segment. And the big one is called as major segment. It's not kernel major. It's basically the major segment. Sorry for the today's jokes. It's not good
Jokes
for
are
the
good.
health.
Good joke.
Yeah. Thank you, Edric. You will get extra marks. Okay, so this is basically the segment that we learn, and I guess this all thing we know from our childhood time. When we say mama, before saying mama, we know this. Okay, so we know all these things. Okay, now today we will learn two more things. The first is second. In trigonometry, we learn sec.
Yeah, sec
In
theta.
trigonometry, we
Sec
learn
theta
sec
and
theta
sec theta and tan.
is basically called as second. Yes, Agatha.
Um. Well, should we write down the formula of major, minor sector, and segment?
No. Right now, no. That is in another chapter, no? I'm just giving you revision. that we learn all these things.
But wait, the major segment formula is theta times 360 pi r square, right? Area.
Theta upon
I'll check again.
theta upon 360 into pi r square.
Theta
If you
upon
want me to write, I will write it down. If you forgot it, it's theta upon 360 into pi r square, and this one is 360 minus theta upon 360 into pi r square. This is the major sector. Okay, now everyone please pay attention. Now we will learn about second part. Okay, so now this is second part. Now everyone please pay attention. I want everyone to listen to my this thing because this is important. Now what is second? Second is a line that is passing through the circle. What is chord? Chord is just a line segment touching the line circumference of a circle, like one circumference to the another circumference, like this. We can check this one circumference to the another circumference. This is a line segment, but second is a line. Simple as that. Okay. So this is called as what? This is called as second. Give me a second. It is second. Sorry. Okay, so this is second. Are you getting this? Okay.
So it's basically a line passing through the circle. That's it.
Yeah, line passing through the circle. It's called a second. Now everyone please pay attention. So how many points are there in second? 2 points. Okay. So I will write this thing. There are 2 points in a second. Okay. Now what is tangent? So we will learn this also. Now what is tangent? Now tangent is a line which is just touching the circle like this, which is just touching the circle. Which is just touching the one point of a circumference. Basically, it means that a line which is just touching the one point of a circle. Okay, so this is called as what? Tangent. And what does this mean? What does this mean? A line that is touching one point of a circumference. That is touching one point of a circumference. It is called as tangent. And 2 point is called as secant. Have you understood?
Yes, sir.
Okay. So now a circle is made up of how many points? Anybody has any idea?
Yes,
Infinite.
0.
Infinite.
Yeah, infinite.
Oh, yeah. Infinite.
Infinite. Okay. So because it's infinite, and we just learned that a line that touch only one point of a circle, it's called as tangent. So how many tangent you can make in a circle? Yes. So there will be infinite tangents to the circle. And we got the point. Now, in the same way, how many seconds will be there? So I told you that second is made up of 2 points. Okay, like 2 points of a circle. So how many points are there? Infinite. And infinite by 2 is again infinite. If I will divide it infinite by 2, it is again infinite, no? Okay. So it means that there will be infinite seconds to the circle, or we can say infinite by 2 if it is more specific.
But still, in infinity divided by 2 is infinity.
Yeah. Okay. Now, can you find? I will give Edric. If you know, don't say. Okay. Let everyone try. Okay. But if don't nobody knows, then I will ask you and the last. Okay. But can you find it out a relation between a secant and a tangent? Like whatever we
So
learned
they're
just
both
now.
touching this point on a circle.
Correct, but not the point which I'm asking.
Okay.
Anybody to give a try? Give a try. Like what you can, like we have secant and tangent in our board right now.
There
Yeah.
are both of them can be in an infinite number.
Yeah, that is correct, which I wrote. Anything special that I don't tell you right now?
They can be formed anywhere.
They can be formed anywhere. Yeah, because that's why they are infinite. No? That is correct point. But I gave this thing. Anything else here finding there's a relation between secant and a tangent?
They both need a circle to like exist. For them to be like a secant and tangent, they both need a circle.
I mean, that is correct. Anything else relation? I'm saying a secant and a tangent relation, not existence about their existence.
So they are both a line.
Wow.
Funny guy, David.
Anything? Directly, just don't. Agatha, give a try. Nobody? Okay. Edric, now you tell me.
Okay. Wait. No, sir. I don't know the relationship between secant and tangent.
You don't know relationship? Okay. Now I will give the relationship. Priya di, Shalini di. उठा दिया.
Hello?
Now listen. See, if I will. Okay. Now tell me, what is this?
Second.
Second. What is this?
Second.
What is this? Uh-huh.
Okay.
What is this?
Tangent.
Tangent. So the relation is, we can say that a tangent
It's like
is a special case of secant where 2 points meet together. Are you getting this? Like in the first line, there are 2 points which are far away from each other. Then when I'm going down to the circle, the 2 points coming near to each other. And then one place came in which the 2 points meet to each other and it become tangent.
I think
Okay.
I have read this in somewhere, but I didn't remember.
Yeah. So we can say that a tangent is a special case of a second where 2 points meets together and become one. Everyone got it?
Got
This is
it.
the relation between second and tangent.
Sir, maths is so fun.
Yep. Done?
Done, sir.
Okay. Now put a heading, theorem. Put a heading, theorem 23.1. Put a heading, theorem 23.1. This is theorem 23.1. What this theorem is saying, a radius through the point of contact of a tangent to the circle is perpendicular at that point. Now everyone please pay attention. Please pay attention. Now this theorem says that, for example, if I will draw a circle for you guys, this is a circle. Now everyone please pay attention. Now what is saying, a radius through the point of contact of a tangent. So first I will make a tangent. For example, this is a tangent. And this is a radius. So the question is saying, like for example, this is a radius and this is a tangent. So this is tangent and this is radius. The OA and X and Y. Okay. So this theorem says that OA is perpendicular. This is the sign of perpendicular to XY. OA is perpendicular. This is a sign of perpendicular. Perpendicular to XY. Means this makes 90 degrees. This makes what? 90 degree. Okay. OAY, angle OAY is equals to angle OAX, which is equals to 90 degree. This is the theorem. Have you understood this?
So, the radius is is it always perpendicular to the tangent?
Tangent, yeah, to the point of contact.
Okay.
They're perpendicular and so the perpendicular of a what was that? Yeah. So the perpendicular and the angle is just the same, right?
The perpendicular.
I mean, like, what's the difference between perpendicular and the actual angle of a circle?
Perpendicular means the 90 degree. Whenever perpendicular is written, then it is means that it is 90 degree.
So OF is perpendicular to XY is just the same as saying angle OAY is equal to angle OAX, which equals to 90 degree.
Yeah. Yeah. The lines are perpendicular to make angle 90 degree. If you write down.
Done, sir.
Almost.
Okay. Now next one. Oi? This is theorem 23.2.
Draw like a circle for this one also.
Now this theorem, I need everyone to find to just pay attention.
Heartbeat बढ़ जाता
Done? Done with the writing part?
For 23.1.
I'm doing 23.2. Wait.
Quickly do it.
तीन महीने का रिस्की है
अच्छा पसीना भाई.
The tangent.
External point to a circle. Equally inclined. Line joining a point.
Yeah. Done? Now this theorem is saying, for example, there is an external point. This is P. This is an external point P. So this theorem says that an external point can make only two lines tangent to the circle like this. An external point can make an external point
तुम्हें लग रही है and I chatting don't decrease
Sir, it looks like
So for example, this is an external point P. So the question is saying that only two tangent can pass through an external point P to the
So is
circle.
that the question or is that the point? Definition.
This is not a point. Everyone first pay attention. Don't write, okay? This is what we are going to learn, that a circle can have only two tangents. A circle can have only two tangents from an external point. So, for example, this is an external point P, which is outside the circle. It can make only two tangents of the circle. This is what the theorem is saying. And this is saying that thing also, that these 2 points, like these two tangents are equal also. So, for example, this is the center of the circle. And if I will draw this, okay, so this is A and this is B and this is O. So this theorem is saying that, what is this theorem is trying to say? Everyone please pay attention. This theorem is trying to say two things. That first is, from external point P, only two tangents can be drawn. Only two tangents can be drawn. And the second point which is trying to say is, both tangents, what are the both tangents? PA and PB. Both tangents are equal. Both tangents PA and PB are equal. Means this line, this PA line will equal to this PA line. Any external point. It's not about here only. If you will make, this is an external point. If you make these two tangents, so these two tangents are also equal. Here, if you make two tangents, these two tangents are also equal. Understood? Any external point, there are only two tangents can be arises from the circle, and these two tangents are equal to each other. This is what is trying to say. Have you understood?
yes, sir.
Understood this thing? Now we are proving it also. Don't write, please. I'll give you time to write. And this theorem, they can ask you, like they will say that this, they will write this sentence, and right after that they will write prove that. Then we have to do this proving part also. Okay.
We
Now,
have to
what is given? Yeah.
So when they ask that question, we have to draw this diagram, the whole diagram.
Diagram, we have to prove all the things.
Ma'am,
All the things which I'm writing, you have to do.
sir,
Yeah.
like, how do we draw the circle? Do we just like draw the circle and then draw like two tangents with scale? Or
Don't you have a compass, Edric?
you don't need a compass. Compass only for construction.
No.
Yeah,
It's
I'm
cons-
using this right now. Oh wait, once I'm using this. Oh no, this thing.
Sir, can we use a compass or some round objects
Yeah.
around us?
Agatha is very
Compass.
Agatha is very studious towards study.
Edric.
Yes.
Okay. Now listen. So what is given? The given is that PA and PB are tangents. Okay. And P is an external point. This is all is given to us. P and PB are tangents and P and external points. Second part. Now what we have to prove? We have to prove that PA is equals to PB. We have to prove that. Now we'll do one construction. We will do one construction, and the construction will be that joined OP. What is the construction? Joined OP. Okay. Now, who knows the chapter congruency? congruency chapter. Okay. Now, what is meant by congruency chapter? Congruency chapter is a chapter in which two triangles, if they are congruent, it means that they are equal. Okay, two triangles, if they are congruent, they are equal in length, area, and everything. Okay, okay. So, for example, we have here two triangles. We have, what are the two triangles? First is O. This one, OAP. This is the first triangle, and the second triangle is OPB. This is second triangle. Okay, we have these two triangles, OAP and OPB. So I will write these things. So in triangle OAP and triangle OAB. Okay, OAP and OAB. OA,
OPB.
OPB, yeah. OPB. Now, we know that this makes 90 degree. Just now we learned this is 90 degree. This is also 90 degree. Okay, both makes 90 degree. Okay, we know this OA is equals to OB because they are radius. We know that this is radius, and we know that OP is and OP are the common. OP and OP are the common. So we'll write all these things. We know that angle OAP is equals to angle OBP because it's a 90 degree. We know that OA is equals to OB because they are the radii. And we know that OP is equals to OP because they are the common. So this is R, this is H, and this is side. So by RHS, we can conclude that triangle OAP is congruent to triangle OPB, means they both are equal. The triangles are equal. And if triangles are equal, then from the CPCT we can say that PA is equals to PB. Now, what is CPCT? CPCT means that if these two triangles are congruent, what does the meaning of CPCT? CPCT says that if these two triangles are congruent, so their sides, their angles, all are equal to each other. So I solved that this triangle and this triangle both are congruent. Hence, PA is equals to PB, means their sides are also equal to each other. Okay.
Sir,
Yeah.
for congruent, why you put wavy line? You should put straight line.
So I put now
You put wavy line. OAP
wavy line also. Wave will also come. Equals to and then above wave will come.
I thought it's 3 dashes.
No, not at all. Write it down quickly. Everyone got this?
Yes, sir. What is CPCT full form?
CPCT full form is corresponding parts of a congruent triangle.
So just because those two triangles are congruent to each other, we can prove that this theorem 23.2 is true.
Yeah. Yes, we can prove. Done?
Yes.
Everyone.
So what is CPCT?
CPCT full form is corresponding parts of a congruent triangle, which means that if two triangles are equal, then their corresponding sides are also equal. Okay, guys. So you guys now will have 3 minutes break. Come back. We will have science class.
Okay, bye.
So why science class?
Because science is science.
David.
Yes.
Do you like type some things to sir on the chat box or only to sir?
What?
Like, do you message sir very frequently in the chat box?
No.
Tell the truth, David.
No, actually I don't.
Oh, you don't. And then why is he blaming you for Agatha?
I don't know. How am I supposed to know? Sir just blames me every time.
Oh, God. Why Agatha?
David, do you mind muting?
Oh, sorry.
Thanks.
Hello. Yes, guys. Come back. Come back, guys. Now, what chapter is there in science?
Work and energy.
Chapter number
Uh,
17.
13.
13. Okay, so we have this chapter, which is chapter number 17. Why it's not uploading? Not upload. Okay, so Okay, now everyone please pay attention. So we have this work and energy chapter. Can you see the changes? Yeah. Oh, wow. It happening. Wow, wow, wow. It is great. Okay, now everyone please pay attention. Okay. So you can see the change also, no? Ah, wow. It's working now. David, you can see the technology. Yeah.
Oh, why are you saying David all the time?
Yeah, I mean, David says, no, sir, I think you are good in this technology.
I
So-
think David is Sir's favorite, Edric.
David. Of course, David is his favorite student, and that's why he's not blaming you, Agatha.
हाँ दीदी ऐसा लगा कटहल लटके हुए हैं साइड में दोनों एक दूसरे को पूरे बुड्ढे
बताओ,
होते हैं
बोलते रहो, बताओ, पतला नहीं होंगे. Okay, everyone please pay attention. So, work and energy. Now, what is work and energy? So, work and energy basically means what is work? What is work? Now, everyone please pay attention. See, for example, there is an object is there, and when object I will put a force on it, then you know what will happen? That after putting a force on this object, the object will move to some distance. Like for example, this is this thing. Okay. So now in this case, what will happen? Because of the force, there is some movement in the some displacement happen because of the force. So that is called as work. Now what is work? I'm repeating again. Pushing or pulling the object so that the object can move. The force which I am doing makes the object to move is changes into the form of work. Everyone got it?
Yes, sir.
I'll ask this question from Agatha. If I'm pushing a wall, this is wall. If I'm pushing it, am I doing any work?
You are, but the object is just not moving.
So is this a work or not?
Work means if work just means that the force we apply to an object, right?
What I told, like we have the example in front of us. In that, what I told, a force
I
applied
thi-
which makes the object to move.
I think
it's
it's
not a work.
energy.
Yeah, that's energy,
Okay.
right?
No. I'm just asking, is it a work or not?
No.
It's not a work. So I'm not doing any work. You want me to tell that, sir, you are lazy. You're not doing any work. Is it like that?
You have put in effort on it, but nothing has happened, so there's no work.
Agatha.
What?
Okay. So, like, what question? I want to ask a question to sir.
Yeah, listen. Yeah, I mean, ask me.
Okay, sir. So, like, we are doing work when we do when like push or pull something across a distance or a displacement. But
Mm.
like, why is homework called work?
Because you are pushing the pen on the notebook. That
And
is homework.
एक बार लाके चले जाओ
Okay. You are pushing the pen in your home only. That is why homework. So pushing a wall is not a work.
because there's
Why?
no displacement.
Because I am putting my force into it, but the wall is not moving. So for work, what is necessary? For work, what is necessary? The necessary is there should be force and there should be displacement. Oh, I don't have any space now. Oh, David, can you see that? And now I make a space. Okay. So what we need a force, and the second thing, what we need a displacement. Displacement or we can say distance also. Okay. So force and displacement, if it is there, then it is called as work. That's enough. That's enough. Okay. But
So, sir, if you just moving this water bottle from one place to another, it is also
when you
work.
are applying, yeah, when you are applying a force on a water bottle, this is water bottle. I'm applying the force, and because of that, the water bottle is uh, doing what? Changing the position. Hence, it's a work. But now I will ask this question from David. David, for example, this is a cardboard box. Okay, I am holding it like it is on the table, and now I am lifting it. I'm doing any work?
No.
No. Why?
It's not. There's no displacement, and it's only
It's
like one.
displacement, no.
Oh no, it's only like it's not moving forward or backward or left or right.
So displacement is not only about forward or backward. It's in any direction. Okay. For example, I'm lifting it. So the like it was on the ground, and now it is on the air because of my force. That is called as work. Okay. Now the question is, I am holding this. Okay, I am holding this. So I will give you an example for that. Okay. I don't want heavenly lights right now. Okay. Now everyone please pay attention. Okay. So for example, I am holding this. Okay. And now I'm moving forward. Is there any work?
Yeah, because the object is moving, but there's no force. I mean, the force is like I don't know, there's no force, right?
Okay. Understand it like this. A coolie came and he's putting the object in forehead and he's moving like this. So is he doing any work?
No,
Yeah.
sir.
We're not working according to physics, I guess. No, wait. I think there is force, right?
But the man is
See,
not
in
applying
this-
force.
I think he is applying force. I
No.
mean,
He's
like
not
the
applying-
Not applying
Okay.
force to the object. The object is just sitting on his head and he's moving. The object is not moving.
so like according
Okay.
to physics, there's no work, but according to actual knowledge, there is work.
Yeah.
Okay, so David is saying there is no force on it. David, take 5 to 6 bundles of books and put it in your head. Will your head hurt?
So 1 second, let me try.
Yeah. Put 5, 6, and if it is not hurting, then put 9 to 10.
Sir, I don't have that many.
Sir.
Yeah.
So there is
Yeah.
force. I mean, sir, listen. The amount of objects we are holding in our head, we need force to hold back that object or its entire image of our head, right? So there is force.
So there is force and there is a displacement also. Why? Because first it was here, and now it changes. The position changes. No, it was there. Now it become here. So now you tell me, is there any force in there? Is there any work or not?
There
Like work is
according
also
to physics and general knowledge. Done.
there is a work according to physics and their knowledge. Anybody else want to say anything? So Agatha is in the favor of that it is a work because force is also there and displacement is also there. Ira, what do you want to say? Yes, Ira, tell me.
But
Is it a work?
yeah, because there's force and object.
So Ira is also in the favor that it's a work and there's a displacement also. So it's a work. David, what do you want to say?
So for the example that you just gave, I feel there is no work.
Why you feel no work? Give me the
I
reason
don't-
also. I want reason also.
Maybe because it's just like there's no it's already on your, like, you already kept the box on your head. You're like, and there's no, like, it's like sitting, it's in one place. So I don't think there's any displacement.
I think what David is
Displacement
trying
is
to
there
say,
now.
there's no force upon
See,
the object, but the person is walking. So that's, I would say it's being
David,
displaced, but there's no
the-
force
the-
upon the object.
I think our head is
See.
like pushing the object away from crushing our brain.
see, the object right now, I'm here. Okay, I'm here, this place. Now I am moving. The object is also moving with me. Now, before the object was at that place, now it came to this place. So there's a displacement, there's a distance. The object travel with me.
So then
So
where's
distance is there.
there's no force there. How's the force?
There is no force. So if you will put 10 to 8 books in your head, will your head is not hurting? Not hurting.
Oh. Okay.
So head is hurting, so it means that the force is there, no? That is why your head is hurting.
So no, but there's no force like being put on the box.
I mean, the gravitational force is there, no? That's why it is pulling towards downward. The books towards downwards.
Sir,
That's
I
why
have
the
a point,
head is
sir.
hurting.
Sir, I have a point, sir.
Yeah. So first, let me ask from the David. David, is this a work or not?
Yes, there is work.
There is a work. Okay. Yes, Edric. Now you.
Okay. Sir, basically, when the force and the displacement are perpendicular to each other, like how you said in the math class, they're perpendicular to each other, then there's no work being done.
I'm not asking about this. I'm just saying, is it a work or not? Yes or no?
It's not a work.
It's not a work. Okay. Why it's not a work?
Because here, because you're not applying like a force to like push these objects and you're moving by your own. So there's no work being done. Work is done when you push the book only like that.
Sir, sir, can I say I have a point in
not-
how there's force how there is force when a book is on our head?
Sir, I agree with Edric.
Yeah, it's there. It's there. See, if you will put a book on your head, okay, the gravitational force is there that is pulling the book towards downward direction. That is why, na? That is why the force is applied. Okay, and you are doing the displacement. So, Edric, the point is not at point what I'm trying to say. But if Edric is saying that it's not a work, so let's take his answer as a not a work. Okay, now Joshua, what do you want to say?
I would say it's a work.
It's a work. Okay, Miracle, is it a work or not? There's a force and there's a displacement also.
Yeah, I think it's a work.
It's a work. Correct. So everyone except Edric is saying it's a work. Now Edric said it's a perpendicular and all this is cos 90. Okay. So basically it's not a work. Okay. It's not a
Sir, I said
work.
in the starting only, but I just couldn't get like I remember this example before about a coolie like putting the box on his luggage on his head and like taking it on his head and putting it somewhere. So I remember that in the textbook they were saying that it's not work. I just couldn't remember why.
Yeah. Okay. For example, this is Miraculin. Okay. For example, this is Miraculin. Okay. Now, Miraculin has put a book in her head and she's moving towards this direction. Yeah.
So how would she put a book in her head?
On ahead. Sorry, on ahead. On ahead. My bad. Now everyone please pay attention. What I'm trying to say, listen, okay. So she put a book on her head and she's moving in forward direction. Now the force is where the force is applying. Downward direction, the gravitational force is attracting towards the downward direction. So the direction of the force is downward. This is the direction of force. And where is the object is moving? The object is the distance is in this direction, towards the right direction. Okay, so they are making 90 degree to each other. They are making 90 degree to each other. Hence, when hence when force and distance makes 90 degree to each other, there is no work. Okay, I will give the reason of this also. I will give the reason of this also. Now, everyone, please pay attention. See, when, like, this is a bottle. Everyone, please pay attention. This is a bottle. I am lifting up the bottle. I am lifting up the bottle. I am doing the work against the gravity. That's why I'm lifting up the bottle and the bottle is moving up. Understood? Okay. So when I am lifting up the bottle or when I'm putting down the bottle, in that case, I am doing work. Why? Because the work is against the gravity. The work is against the gravity. The force which I am using is against the gravity. But when the bottle at one place, like for example, this is a stationary place, or on my head is a stationary place, and when I'm moving towards the forward direction, then what happened? There is no work against the gravity in that case, because I am not doing up and down. I am just going forward and backward. So
sir,
the work against the gravity will be zero. In that case, the work against the gravity will be zero. Yes.
so if you're bringing a heavy suitcase from up a cabin to the if you're bringing a heavy suitcase from above the cabin to the bottom, there's basically no work in terms of physics.
From up cabin to the down, if you are putting, you are doing work. You are doing work. Okay. But if you are putting that suitcase, putting on your head and moving in forward direction, you are not doing any work against the gravity. That is my point.
How can we are bringing the suitcase down with the gravity, not against. It's not even against the gravity.
So gravity is pulling, no? Gravity is doing work.
Yeah. Oh yeah.
Gravity is pulling, gravity is doing work, which is pulling the object towards downward direction. Okay. So if I will put a book and if I will do squats, am I doing any work?
Yes.
Yes. I'm putting a book on my head and I'm doing squats. I'm doing the work. Why? Because in
So where's the
squats the
displacement?
movement is up and down, up and down, up and down. Yeah.
But where,
Yes, yes.
So you had said if I put like 6 books on my head, it would hurt, right?
Not 6. If it is beyond your strength, then put 10 or 20.
So I'll put a
and-
dumbbell. So,
Very good.
so
Now
5
jump.
kgs.
Now
Wait,
jump,
one
jump.
second. Ah,
What if the book falls down?
yes.
Like,
Sir, I jumped.
I want to tell you a thing, like it's out of the syllabus. Like I want to tell, like, look, like Hardik sir takes so much effort to make us like to understand the topic. Like he also become a coolie for last 5 minutes.
Yeah, see, I'm Cooliwala. Perfect. Okay, so we got these 3 points. The 3 points is when there will be no work. So there are 3 points in that. The first point is there is a force, like you are applying the force, but there is no displacement. But there is no displacement. Can you give me an example? Can you give me an example of this? There is a force, but there is no displacement. Anybody?
So when you're like trying to push a heavy object, but the force is not enough.
Yeah, pushing a ball. PMM ko do. PMM ka hai?
like
Priya,
pushing
ma'am,
a ball. Pushing a
Yeah,
wall.
pushing a wall. Pushing a wall. So I'll write a pushing a wall. Okay. Now second, just now we learned when force and displacement. When force and displacement makes 90 degree. Just now we learned. What is the example for that? Example, cooling, not coolie. I mean, not cooling, it's coolie. Coolie. Put object on head and moving forward direction. Moving
It's
forward.
not. I think it's not KULI. It's COOLI.
Yeah.
Oh,
Like
okay.
Miraculous. Like there's a movie called Coolie.
Yeah, actors movie. I know that.
Rajini.
Yeah, Rajni.
Okay. Okay. Now come back to our physics. No Rajni, no Pajni. Okay. Now, the third thing is when there is a displacement, but there is not a force. But there is not a force. Anybody can give me the example of this? There is a displacement, but I didn't apply the force.
So gravity would count as force, right?
Gravity will come, yeah, but in this it won't.
So then a ball rolling down a hill. Would it
Yes, we can say.
A waterfall, sir?
But doesn't
Waterfall,
waterfall
no.
fall because of gravity?
Yeah, gravity it's falling and the displacement is also downward. So they are not making 90 degrees. So waterfall, there's a work.
So the only thing that comes to my
Anybody
mind is
else?
a video game. You know, the video game.
I'm thinking for this.
So what about like
David,
Yes, sir.
you're doing googly.
So what?
Okay. So for example, there is an inclined surface, and from that the ball is rolling down. Okay, so the ball will roll automatically. If I will just put it, the ball will roll automatically. Okay, so in that there is no force, but displacement is there. Okay, hence there is no work.
So gravity does not count as force.
Yeah, gravity will count now, but gravity is putting force in downward direction. No.
Yeah. Okay, sir. Sir, you have very nice drawing skills.
Thank you. Thank you. Thank you.
Guys, I want to show you a thing.
Yes.
Either.
What is that?
Is that a bunny? Oh.
Yeah.
What's
Yes.
her,
What?
what's her
I
name?
missed that. I missed that. Show me again.
Miraculous, what's her or his name?
Snow.
Snow. Is the girl or
Yeah.
a boy?
I don't know the gender right now, but
Oh, it's still a baby or something?
mid-age.
Mid-age.
Okay. So we learn about the work. So I request Agatha to please read this from this, please.
I should read. Okay, work is a common term we use in our day-to-day conversation. Ordinary, we include stand-in, read-in, line, etc. in the category of work. But in science, physical work has a very specific meaning. That is, work is said to be done when forces are applied on a body and the body moves through some distance in the direction of force. To elaborate, it implies that if a force is applied on a body and the body does not move, then no work is done at all. Example, when you try to push a ball, you do not do any work as distance moved by the wall is zero. Next point, if no force is applied on a body and the body is either at rest or moving with a constant velocity, then again no work is done. Example, a car moving with a constant velocity on a level road does not do any net work because the fuel it consumed is used in doing work against fraction. Is it friction or fraction?
Friction. Friction.
So that its velocity may be maintained. What is this example? A car moving with a constant velocity on a level road.
Okay, now what does this mean? Okay, who knows about car? Little bit about car. Car is a four-tire system, like four tire it has. Everyone knows that. Okay. Now, I think mama, dada or their friends, they used to talk like that this car gives good mileage on highway rather than mileage on the city. Like we heard this thing. Okay, what is mileage? Mileage is kilometer per liter. Okay, how much kilometer it will run in 1 liter. So basically, like I have car. So in the car in city, it gives me 16 kilometer per liter. 16 kilometer per liter means 1 liter it will consume and 16 kilometer it will run. But on highway, it gives me around 23-24 kilometer per liter. Okay, what does this mean? That on highway, when there is no brake, when there is no more vehicles are there, when car is moving in steady speed of 80 and 90 kilometer, it will give me 24 and 25 kilometer per liter. So why there is an increase in the mileage? Because when the car is moving steadily, when the car is moving steadily, I don't have to work on acceleration. Means I don't have to put car in under the force. Like acceleration is there is a force. Okay, acceleration means force. So when the car is moving in leveled roll, when there is no brakes, when there is no car, there is no brakes. Okay, in that case, the car doesn't experience any work because it's moving in a constant velocity. That's why it consumes less petrol to walk more kilometer.
Yes. So so there's displacement but no force.
Yeah, no extra force because acceleration is stable. Like my acceleration pedal is stable. 80, 80, 80, 80, 80, 80, 80. Okay.
So,
As
sir,
the velocity is constant, there is no acceleration. If there is no acceleration, there is no force.
so if we keep applying the same force on an object, there will soon be no work.
No same force. For example, I am pushing a trolley. I am pushing a trolley. Okay. In pushing the trolley, if I am increasing the speed or decreasing the speed, means the trolley was very fast, now becomes slow. Or the trolley was very slow, now it become very fast. It means that I am putting an acceleration. What is acceleration? Acceleration is increase or decrease in the speed. This is called as acceleration. With the time, if there's an increase and decrease in the speed, it is called as acceleration. And acceleration occurs because of the force. Okay, acceleration occurs because of the force. But if I am pushing the object with the same speed of 2 meter per second, same speed, 2 meter per second, there is no change in the speed. If there is no change in the speed, there is no acceleration. If there is no acceleration, there is no force. Hence, there is no work.
Okay, so since there's no change, so acceleration is the change of speed, and since there's no acceleration in constant, if a car is going in a constant velocity on a level road, then that is why there's no force.
Yeah,
no-
there is no force and there is no work. Okay. And the third point is if force and displacement makes 90 degree, that we learn like a coolie. I made a coolie for you guys. So did you understand this concept? Under three conditions, there won't be any work. Force, no displacement, no force, displacement, work and force 90 degree. Everyone got this?
Yes.
Okay.
Yes.
Then if you got this, so we'll end this class